Thanks to Jim and thanks for everybody. It's really happy to be here. All right, my dry run did not include a microphone, so I'm already behind schedule. All right, cleaning up your Python Superfund site. So this talk isn't really about Python. This talk is about effective usage of containers to isolate your application from its environment. One of the things that does for you is it happens to clean up your Python Superfund site because you're not installing everything locally. So ideally what I would like to do is have everybody come out of this talk with a good idea of what you can get out of containers and how to apply them appropriately. So there are 4 tools that I think you can think of as concentric circles around your application that they're going to isolate your application from its environment. Virtual environments, whatever package manager you like, whatever flavor you like of that. The actual virtual machine container Docker, and then your service composition, which is a Docker Compose file. That's a group of services inside of a natted firewall that all run on your machine. And that's what I really want to talk about, because I think that's the part that people don't really get about containerization. It seems silly and redundant, I think, particularly when you're looking at a simple example. So we're going to take an open source high-frequency cryptocurrency trading bot that has a Docker file and a virtual environment, and we're going to add a Docker Compose to it. OK. So a Docker Compose file just starts with a version and then a list of services. So this is all YAML. It's all really very straightforward. And we're going to set up a service for our application. And we're going to point it at just the regular Docker file. Question? Oh, yeah, I probably can. We can get pretty big with this. OK. And so that's all you actually need to tell your Docker file, hey, there's a service inside of this that you should spin up. This is a pretty trivial example, and so it doesn't actually do much for you right now. But you can see here, I have a Docker Compose aliased too. OK. So I did something wrong in here. Oh. All right. All right, so a lot of the Docker commands map one-to-one from Docker to Docker Compose. So run, build, exec. So if you're familiar with Docker, you're familiar with Docker Compose. But Docker Compose has some other ones. PS, which is to look what's running up, which brings everything up, down, which brings everything down. So like, for instance, we could just run Docker build right here, and it looks for the same Docker file. Like, just that's how you would build it regularly for Docker. But we can also do Docker Compose up, which starts it inside of this natted firewall. OK. And so what we're seeing here is this is the output from the container that's running inside of your service collection. And then you've got on the very left side where it's coming from, which is the application, and then whatever the logs are. This is actually running in like a dry run mode. It's pretending like it's trading cryptocurrency with an exchange. OK, so that's cute, sure, but we don't really have anything interesting yet. So a good example, I think, is a testing service. So, oh, and don't write Docker files from scratch. Copy them. They like makefiles. OK, so we've got this PyTest service, and I know from having done this that it actually needs a different Docker file. And oh, that's nope. And we'll just have it mount the same code. Now, you can have any number of volumes to map here. Right now, this is just mapping everything, but you don't necessarily always want to do that. You might just want to map a subdirectory or some smaller part of your application, not the whole thing, but we're just going to do the whole thing right here. Okay. So let's stop this, and I like to make sure that everything's down before you bring it back up. Sometimes if the network is still up, it gets upset. Okay. Oh, right, it's looking for a command. Okay. Okay. All right, I think that's what it wants. No. Okay. All right. So that didn't work out very well, but I just hard reset it to the branch that does work. So we can keep doing this. All right. So we've got our application up here. This is the one that we had before. It's got 3 volumes mounted, and it's got a different Docker file that's installing the libraries for Postgres. So this is what we're going to use to add the library. If you just spin it up by itself, it'll like set up SQLite in your application, and that's great, and it's ephemeral and whatnot, but sometimes you want to have a real database. We've got another service down here. This is what I was attempting to add. This is a PyTest service, and if you go out and look at their coveralls and then their Travis job, you can just grab their PyTest runner, and then I dropped that into this PyTest script. So let's actually do the. Let's bring it up like that. Well, that's pretty fair. Okay, so now we're seeing 2 of these instances come up. You've got your application, that's the one that's in yellow, that's Freak Trade Postgres, and then you've got PyTest. The PyTest service is running all of the unit tests that you would normally run, but it's starting them up in parallel as you start your application. So this can be really handy. The more often you run your tests, the more often you're going to find they're broken, the easier they're going to be to fix. So having it just built into your repository such that I don't have to go run a test, I don't have to do anything, I don't have to explain to somebody where they are or anything. The README just says, start Docker up. Okay, but again, this isn't particularly interesting. You can run tests, you just have to remember to do it. Okay, so now, okay. So now I want to talk about the difference between built images and pulled images. So Docker Hub is a service like PyPy where you've got open source images. There are these containers that live out there, everything you'd ever want to run. And so for PyTest and Freak Trade up here, we're actually building these local Docker files. They're compiling on the machine, they're building the layers, and they're loading into Docker cache on the machine. But this one down here is an image, and it's just pulling Postgres. And I know that that's an image because I use it all the time, and I also have that cached. All right, so inside of, you've got this big natted wall, that's your container. Inside of that, you've got services, and expose is how you tell, this service that it's got access to a port. So this is allowing anybody outside, but not outside of the container, but it's allowing the other services to connect to this database. So okay, so now we've got a database. we've got our application and we've got our unit tests. The unit tests are going to run, and then it's going to go pretend that it's going to trade. Okay, so now, depends on. This is simply just a directive that tells Docker Compose to not start the database before it starts your application. It doesn't do a health check. Docker used to do that, but I think there's a strong argument to be made for your application should be robust, right? If it doesn't find the database, it shouldn't blow up. And this is a good way to be able to see that, test it, think about it. Well, if we bring that back up, it'll start the database and it'll start the application, I promise. Okay. And then toolkit is a little one that I like to leave around because, okay, so Docker files are intentionally as small and as light as possible. You ideally want it to be really fast to build and really fast to deploy. So you don't want to have any extra stuff on your image. So Alpine images are, they're images that have been created for a specific thing. They just do one thing. So say it's Postgres, it's a database, maybe it's, I don't know. There are lots of things out there, but you can't really expect to find anything on there. So for instance, if you wanted to hop in there and like ping or look at a port, you just can't do that. So the exec command, well, first let's look at everything and see that it's up. Okay. So we've got our 4 services, and then we can go into this toolkit, and this is the command that it passes in. So it passes it in as a shell. That's the way that you get into Docker Compose. You can see the command that toolkit is running on the 4th line down there is it's tailing a file called forever.txt. So it's basically just watching tail do nothing. In my little toolkit, I do have ping. And so you can see that Docker Compose is automatically, you see that ping to DB. Docker Compose does name resolution of your service names with all of the other service names inside of your container. And we can also oh, I'm cute. Not sure I'm doing that wrong, but we could just do that. And we can see that the port is open. Cool. Okay. So having a Docker Compose file that defines all of the services that your application needs gives you a lot of things. It allows you to store all of your external dependencies in a reproducible version-controlled environment that doesn't fall out of date. I mean, I'm sure everybody here has dealt with a 2-page long README that takes a day to install, and then after you've done it, somebody says, oh yeah, well, no, don't follow that. It's wrong, it's out of date, right? So the README can be wrong, but the code can't. So if you're always spinning up your application with your Docker files and in your Docker Compose, you all of a sudden have a very reproducible environment where you've isolated all of the external dependencies, libraries, which version of Python you're running, and then obviously everything you've done in your package manager. That all exists in a reproducible place, such that ideally you could just have a README that says download Git, download Docker Compose, and run Docker Compose up. So think about the project that you're on right now. And let's say you got the task to onboard a really, really great developer tomorrow. How long would that take? How much of your time would that take? How much of that developer's time would that take? And this works just as well for context switching back to something that you wrote a year ago on maybe a different machine. You can seamlessly move back into the project, run Docker Compose up, and see that everything is working, or that it isn't. Okay, we talked about build versus pull, name resolution. We talked about depends on, ports versus expose. Cool. So expose, this is, I think they named this terribly. Expose opens the ports to the other services inside your Docker Compose service catalog. Ports actually pokes a hole in the external NAT. So let's say you're not like me and you have a GUI that you like to use on your database. You can open up any port. So you could map, port 15432 from the external interface that just shows up on the local host into the database that's in your service, and then get in there with data grep or whatever it is that you like. So we set up we set up a unit testing service in there that you can run, and you don't have to spin everything up at once. You can start 3 or 4 of them and then start another one. This works. Unit testing is kind of a contrived example. This works really well with integration testing. So throw a database in there, right? We saw how to do that. It's really easy. It's really fast. Throw a service in there that loads fixtures, right? Have that start up after the database, and then a service that performs integration tests. So like, let's say you're building out a Flask API that's got a database behind it. You could have your application, your unit tests, your lint tests, full suite of integration tests, all just run inside of this Docker Compose. Now all of a sudden you've got this encapsulated, portable thing that runs anywhere. And you can just move that right into your CI/CD pipeline, or upload it to ECS, or however you want to deploy your stuff. All right, so there's some links down here. Freak Trade is the open source high-frequency trading bot that we wrapped. It didn't really matter that it was this. It didn't actually even matter that it was Python. But I do think Python, as the slide showed, Python has a reputation for messy virtual environments. And so I think it's a good language to use to really think about this. I did put a PR out for that. And then these were the links to the code coverage and Travis job that I pulled the test runner stuff from. Okay, so now I was going to talk about Docker file structure. Right? Okay. So I don't know how familiar everybody is with Docker files, but so if you're a Docker expert, this might be kind of boring. Up on the top line, the from is just saying that we're going to pull an Ubuntu image. This is on Docker Hub that already has Python installed. It installs a couple other things that are required for the application. And you'll notice these are all on one line. What that does with Docker is when Docker processes the file, it executes that entire line, and that creates a layer that Docker then caches. So the next time you spin it up, and you saw that it built that really quickly, I think. The next time you spin it up, it doesn't rebuild any of the layers that are exactly the same. So if you don't change the Docker file at all, it's just a few seconds to start the machine back up. And if you change something all the way down at the bottom, it's also still just a few seconds, because it's going to use this very last layer and then just do something very little on top of that. Being able to run your tests effortlessly and quickly is really nice. It means you're going to run them more often. It means you're going to find when your stuff's broken. It means you're going to fix it. Okay, we talked about Alpine images. Okay. So this, I think, is a good example of this is a this is an API, this is a database, and it spins up, and this is a little app that wraps Alembic, which is an ORM, and so this is just for migrations. It spins it up, it runs all of the migrations, runs them up, runs them all the way back down, and then runs them all the way back up. So once you've run this Docker Compose file, you can be sure that all of those migrations are going to run flawlessly once they get out. All right, and now I think we can do some questions.
Yeah, quick question on Docker images and how you might compare them to, let's say, PyPI images in terms of their provenance and basically the level of trust that you ascribe to them.
I mean, I think they're very similar. I mean, if you want to pull in a PyPI package or if you want to pull in a Docker image, you should go look through it and you should check and make sure that everything is legit. I definitely know that they had an issue with some people publishing well-known images that had a miner that was actually running in the background a few months back, which it's cool to live in the future, but that's a dick move.
Hey, great speech. Could you talk a little bit maybe about kind of how it's containerized and what that means in terms of if you have a virtual machine, is it limited in terms of RAM or kind of any of the specs of the machine?
I don't actually know the answer to that question.
Okay. I guess I could do a separate one then. Could you talk a little bit maybe about the big differences between maybe Docker Swarm versus Docker Compose?
I've never actually used Docker Swarm either. Sorry, I'm failing you.
Okay. No, it's not a problem. Thanks.
Thank you.